This simulation shows how a simple DC motor turns electrical energy into mechanical rotation. On the left is the North Pole magnet, and on the right is the South Pole magnet, creating a magnetic field pointing to the right. The battery sends current through the brushes and into the rectangular coil in the center. When current flows through the coil inside the magnetic field, each side of the coil feels a force in opposite directions. Those opposite forces create a turning effect, or torque, which makes the rotor spin. The green moving spheres show the current path, and the amber arrows show the magnetic force acting on the coil. In split ring mode, the commutator reverses the coil connections every half turn, so the torque keeps pushing in the same rotational direction. In slip ring mode, the current does not reverse, so the turning effect changes with angle instead of producing continuous one-way rotation. You can also toggle magnetic field lines, switch between conventional current and electron flow, adjust speed, and step through the motion to see exactly how the motor works.